Hi student, welcome to chemistry class with Odison Olalekan Adiola. This video is brought to you by Igota Virtual Learning. And in this class today, we are going to be learning about the periodic table. The periodic table. Now let's start with the periodic table. What does a periodic table mean? The periodic table is a table that shows how elements are arranged based on their properties. Of course, you'll be aware that we have about 120 elements in chemistry as of today, and of course, the periodic table carefully arranged them based on key properties, and as a result of the similarities or differences they have in their properties. So, in today's class, we are starting with the development of the periodic table. Now, the first periodic table was created by Dmitry Mendeleev in the 1800s, and of course, at this time, elements were arranged in order of increasing atomic mass. In the first periodic table or classical periodic table, elements are arranged based on in order of increasing atomic mass. So as a result, or of course, atomic mass also mean a mass number. They were arranged based on mass number. Elements with similar properties were listed side by side, and it was discovered that there were repeating patterns to these properties. They have a repeating pattern which is called periodicity. The repeating pattern of properties of elements is called periodicity. So there are repeating patterns in this. So elements are arranged based on that. Then, interestingly enough, Mendeleev left blank spaces where the pattern shows elements should exist. So that is how the the classical periodic table was designed. And the interesting part is that the spaces that Mendeleev left, so that other elements could fill in. Years later, those elements were discovered. Now, quickly look at the first picture that shows the Mendeleev's periodic table. Here you have how elements are arranged from 1 to 8, and then based on similar properties that they possesses and based on their atomic mass. Okay, we also look at a modern way by which Mendeleev's periodic table was arranged. You could see from group 1 based on their atomic mass. So he left spaces, you will see spaces, some spaces immediately after calcium there is a space. Then immediately after tungsten there is also a space. So at the long run, these elements were. So this is a typical structure of Mendeleev's periodic table. Now, the next thing we look at is the modern periodic table. The modern periodic table. The modern periodic table was rearranged by Henry Moseley in 1913. Now, in the modern periodic table, elements were arranged in order of increasing atomic number. Why? Because the atomic masses did not always fit this pattern. So elements in the modern periodic table were arranged based on atomic number. For the first periodic table or the classical periodic table, they were arranged based on the atomic mass. But the modern periodic table is arranged based on atomic number. Now, you will see how a typical modern periodic table look like. You have group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In between them, you have the transition elements. Group 1, you have group 1 members. Of course, you should know that hydrogen was picked up, or hydrogen sometimes in the periodic table, hydrogen is left on its own for two major reasons. For hydrogen generally now, is put in group 1 because it loses one electron to have a zero configuration. But in actual sense, hydrogen can lose one electron or gain 7 electrons to become a noble gas. It could gain 7 electrons to become a noble gas. That's H minus. It becomes an hydride. But when it loses 1 electron, it becomes H plus. So it has a 0 configuration. So hydrogen can be in group 1 or group 7. And that's why in modern diagrams now, you will see that sometimes hydrogen is put at the middle, having no group, because it could be in group 1 or group 7, as the case may be. But for the purpose of this study, hydrogen is still placed in group 1 because primarily group 1 has 1 valence electron out the outermost shell. You have a group 2 and the like. So this is how a periodic table look like. Then you have group 13. You have the group 13, which is sometimes they call them group 3 as well in other diagrams. You have group 14, group 15, group 16, group 17, and group 18. So group 18 are called the noble gases. Group 17 are called the halogens. Group 16 are called the chalcogens. Group 16 are called the chalcogens. Group 15 are called the nitrogen. They are called the nitrogens. Group 14 are called the carbon family, and group 13 the aluminium family. So group 2 are called the alkali earth metal. Group 1 alkali metals. In between group 2 and group 13, the 3, 4, 5, 6, 7, 8 to 12 that are in between these two, they are called the transition elements. They are called the transition elements or the transition metals. Then you have at the bottom here, you have the lanthanide series, and then at the bottom, the last bottom, you have the actinides series. So the lanthanide, so both of them, both lanthanides and actinides, are F block elements. Group 1 and 2 are S block elements based on electronic configuration. Now, group 1 and group 2 are S block elements. Why? Because they end with S in their configuration. In this middle, from 3 to 12, they are D block elements because they end with D. They are transition metals. The 13 to 17 or to 18 are P block elements because they end with P block, while the lanthanides and actinides are F block elements. This is a typical modern periodic table. Now let's look at the periodic law. The periodic law is important because it gives us an insight into how the modern periodic table was arranged and the progression or patterns of their properties. The periodic law is a statement about the behavior of elements when they are arranged in specific order. The periodic law is a statement about the behavior of elements when they are arranged in specific order. The periodic law states that elements with similar chemical properties occur at regular interval or periodic interval when the elements are arranged in order of increasing atomic number. To put it and in another way, you could state that the modern periodic law states that the properties of elements are a periodic function of their atomic number. The properties of elements are a periodic function of their atomic number. So this could be put in this way as well. And we can see that the way the modern periodic table were arranged is showing there is the elements have recurring properties. Elements within a particular group or period have recurring properties, and based on how the increasing atomic number. Okay, so let's look at how a typical periodic table is. In a periodic table, you have the groups and the periods. When you are moving down like this, you have the groups. When you are moving from left to right, when you are moving from top to bottom, you have the groups. So you have group 1, group 2, group 13, 14, 15, 16, 17, and 18. Then when you are moving from left to right, you have your period. And that's why you have period 1, period 2, period 3, period 4, 5, 6, 7. So we have 8 groups, and in a typical periodic table, you have 8 groups and 7 periods. 8 groups and 7 periods. Now the periods contain different number of elements. We have period 1, we have period 2, we have period 4, we have period 6, and we have period 7. We have 7 periods and 8 groups. Please note that in when you are talking about periods now, properties of elements change as you go across a period. The properties of elements change as you go across a period. Number 2 that you should take note of is that the patterns of properties within a period repeat in each period. The patterns of property within a period repeats in each period. This is called periodic law. Now, each period represents the number of energy level holding the electrons of those elements. So when you see a period, when you see periods, it talks about energy level. For instance, in period 1, they had energy level 1, period 2, energy level 2, period 3, energy level 3, and so on. So each period represents number of energy levels holding the electrons of those elements. Now, another, apart from the periods, you have the groups. Elements within a group have similar chemical and physical properties. Elements within a group have similar physical and chemical properties. In fact, for groups, one thing is common to them: they have the same valence electron. Valence electron means electrons are the outermost shell. Elements within a particular group have the same valence electron. For instance, group 1, their valence electron is always 1. Group 2, their valence electron is 2, and so on and so forth. Please take note of that. Very, very important. Now, in a typical periodic table, you have metals. Elements are classified based on their properties now as metals, metalloids, and non-metals. So, if you observe very well in this periodic table, you have elements are predominantly classified as either metal, non-metal, or metalloids or semi-metals. For semi-metals could behave as both metals and non-metals. Usually, you have group 1, group 2, group 3 as metals. Then in between, you have the deep lock element, the transition element. Group 3 to 12, they are also called transition metals. Group 13 is also a metal. Now, 14, 15, 16, 17, 18 are non-metals. However, in between, especially group 14, group 13, 14, 15, you have metalloids. You have, for instance, silicon is a metalloid, germanium is a metalloid, and so on. So, generally speaking, we have the metals, the non-metals, and the metalloids in a typical periodic table. How do we know the metal? Metal exhibits most metallic properties. All metals will exhibit most metallic properties, like they are good conductor of heat and electricity. Their surface can be polished. That means they are lustrous. Then another one is that they are solid. Most of them are solid at room temperature, with the exception of mercury, which is liquid. Most of them are ductile and can be drawn into a thin wire. Most of them are malleable and can be powdered into thin sheet. Another one is that most of them are sonorous. That means they give sounds. They have high tensile strength, and so on. These are few properties of metals. Then you have non-metals as well. They have properties that are opposite to that of metal. They are not malleable, not ductile, not lustrous, and so they are poor conductor of heat and electricity. Most of them are gases at room temperature, with the exception of bromine, which is a liquid, sulfur and phosphorus, which are solids. They are brittle, and so on and so forth. These are their properties. Then you have the metalloids. Metalloids are also called semi-metals because they have properties between metals and non-metals. Sometimes they behave like a metal, sometimes they behave like a non-metal. They have two properties, so they have mixed properties. Now, quickly, we now discuss the groups, important groups within the periodic table. Generally, we have group 1, which are lithium, sodium. Members of group 1 are lithium, sodium, potassium, rubidium, calcium, and francium. The alkali metals. Group 1 elements are called alkali metals because they dissolve in water to give an alkali. That's why they are called alkali metals. They are found in group 1A or in group 1. Another interesting thing about group 1 elements is that they have one valence electron. That means the electron at the outermost shell is 1. They are S block elements because they end with S block. They are highly reactive and are not found in nature. They are not found free in nature. They are very reactive. They are not found free in nature. Then they react with water to produce alkali and release hydrogen gas. So those are key properties of the alkali metals. For the alkaline earth metals, they are found in group 2A or group 2. Members of that group includes beryllium, magnesium, calcium, strontium, barium, and radium. And they have 2 valence electron. They are also very reactive, but not as reactive as the group 1. Then in between group 2 and group 3, you have what is called the transition metals. You have the first transition series, the second transition series, the third transition series, and so on. The transition metals are found between group 3 to 12 or between group 3B and 2B. They are characterized by having d orbitals. That's why they are called the d block element. They end with d, and then they have a lot of properties. One of them is they have colored ions. They are also good conductors of heat and electricity. They have high tensile strength. They can be used as catalysts. They have variable oxidation state. And they form complexes. These are properties of the transition metals. Now, inside the periodic table as well, you also have the inner transition metal. They are also called rare earth metals, where you have uranium, europium, californium, etc. Then for the inner transition metals, they are F block elements because they have F orbitals, and then most of them are usually man-made, especially elements beyond uranium are all man-made and they are radioactive. Another one is halogens. The halogens are found in group 7A or in group 17. They have 7 valence electron. They are the most reactive of the non-metals because they have high electronegative values. In fact, fluorine is the most electronegative element. They are very reactive. The halogens, they will react with many metals to form salts, which are called metal halide. An example is when sodium reacts with chlorine to form sodium chloride. So they are gases at room temperature. They are diatomic gases. They exist as Cl2, F2, and so on. They are colored as well. Fluorine, for instance, is yellow. Chlorine is greenish yellow. Bromine is reddish brown. Iodine is black, and of course, so they are colored, and then they are very, very reactive as well. Okay. Then another one is the noble gases. The noble gases are also called inert gases. Elements within this are helium, neon, argon, krypton, xenon, and radon. They are the least reactive of all the elements that are present there. So these are properties or description of the periodic tables. Let's quickly take a particular question. WAEC 2012. Look at the question very well. Based on the electronic configuration, you're expected to state elements that belong to the same group, same period, readily ionizes by losing electrons or gaining electrons, is or are noble gases, or we have to form electrovalent compounds. So let's look at the question. Now, the first question talks about the first thing to do here when you are solving question relating to this is to, from your knowledge of electronic configuration, predict what element it is. For instance, in this answer I said Q is boron, S is aluminum, R is magnesium, U is chlorine, and T is neon. So the one that belongs to the same group is the Q and S, which is which is boron and aluminium. They belong to group 3. The ones that belong to the same period are the one that belong to the same period are RSU and Q and T. The RSU is magnesium, aluminium, and chlorine. They belong to period 3. Then Q and T belongs to period 2. So then another question is the one that ionizes by losing electron. The one that ionizes by losing electron easily, Q, R, or S, we ionize by losing electron because they are what? Because they are metals. Metal ionizes by losing electron. The one that ionizes by gaining electron is chlorine because it's a non-metal. They gain electron. The one that is a noble gas is T. That's a neon. And then the final one is we have to form electrophilic compound. R and U, that's a magnesium and chlorine co-react to form electrovalent. Aluminum and chlorine also react to form electrovalent. Boron and chlorine also react to form electrovalent compounds. And the second one, very also similar to that, is WAEC 2003. The first thing to do again is to list the metal. P is carbon, electron of 6. R is neon. T is chlorine. Q is oxygen. S is magnesium. And very simple, they said the one that belongs to group 6, that's oxygen, that's Q. The ones that belongs to that is strongly metallic in character, that's magnesium. It belongs to group 2, alkali earth metals. The one that loses electron, ionizes by gaining 1 electron, that's chlorine, that's T. The one that contains 2 unpaired electrons, 2 of them could compete unpaired electron. If you draw the orbitals like we have treated in the previous topic, carbon will have in the p box 1 1 each, which are unpaired, and an empty pz orbital. The px py have 1 electron, pz is empty, and then 1 electron. Since they have 1 electron, they are unpaired. They have 2 unpaired electron. Another one is oxygen. Oxygen have p4, so you fill singly first, px py pz, then you double. By the time you double, your px is complete, is filled. Your py and pz, they are unpaired. So you have carbon, that's p and q, having 2 unpaired electrons in their ground state. Then the question says readily loses 2 electrons during chemical bonding, and that's magnesium. We lose 2 electrons in chemical bonding. The one that does not participate in chemical reaction, that's a noble gas because it's inert, that's R. The one that is an X block element, the one that ends with S, and that's S, that's magnesium. So this is questions on WAEC, and you can lay your hands on other questions as you see fit. And in the next video, we are going to be looking at the properties, the key properties of the periodic table, where we talk about ionization energy, electron affinity, and so on and so forth. Do well to read over these questions again and solve on your own. Take more questions and also solve on your own. Continue to learn chemistry. Bye.